A warm welcome to another episode of Dina and Mina show from Digital Health Days 2015. And right now we have Professor Anthony Turner, who's one of the leading names in the world of biosensors, with more than 750 publications and patents. Professor Turner is also the head of the Biosensors and Bioelectronics Center at the University of Linköping here in Sweden. A warm welcome here.
Thank you very much.
And I would like to start strong. You developed a first glucose sensor back in 1980s. So how much has changed in the world of biosensors since then? And what is your vision for the next generation of technologies to come?
Well, thank you. I mean, we developed the first electrochemical glucose sensor because there were optical devices and color change devices before then. The world has changed a lot since those days. When I started in 1980, there was about one publication a year in biosensors. Last year there were 6,000 publications, and there's about 60,000 papers altogether out there. So there's a lot of stuff being done and a lot of academic interest. Nanotechnology has had a huge impact as well as on the materials that are being used there. But in terms of practical outcomes, first of all, we've had a number of successful devices, both in terms of supporting drug development and behind-the-scenes type devices, as well as those being used by the general public, such as the glucose sensor. Diabetes has been a hugely important area for biosensors, and some of the big milestones there have been implantable devices and real-time monitoring. That was a major milestone in 2005. And now we also have sort of wearable devices that you can swipe and get the information. Where I'd be slightly disappointed is that we haven't done or scratched the surface of the possible. There are many, many hundreds of things that we can measure, that we need to measure.
Like?
Well, you can start off with, there's the technical things, like you can measure various metabolites, like lactate, like cholesterol, and so on. You can measure various markers, like markers for cardiac disease, cancer markers. We can look at particular enzymes, like stress markers, G6P, and so on. You can look for infections and inflammatory markers. You can look for genetic markers, and there is just so many things. The problem is, where do you start? Which one do you go for that can support the development costs? Because although we make simple, easy-to-use devices, that's a little bit deceiving, because it actually takes a lot to make a simple device. It takes a lot of development time, a lot of money. So you have to have big needs and big markets. And for example, I would say that one big need that is very under-recognized at the moment is kidney disease. Huge problem with kidney disease, a huge demand and a huge cost to healthcare services. So early screening for kidney damage, I think, would be perhaps the next killer application that everybody keeps asking me, what next after glucose?
Just a tip for all following entrepreneurs.
In your very interesting presentation, you also highlighted the fact that biopharmaceutical companies were the big players in the field of devices. They were providing devices for different measurements. But now you also mentioned that software companies are taking over. What is your vision? Where is that going?
Well, what's happened is it's quite interesting, because some people have regarded, some commentators and some companies have regarded the biosensor field as a mature field. In other words, it's done what it's going to do, and you milk it for money now. And so you find some of the established winners in the field have begun to think that they don't want to invest in new technologies. They just want to do improvements, engineer it, and market the product more heavily and get their money back, if you like, for the investment that they've made. But other people have a completely different vision, a vision that I share, that we're just at the beginning, that everything's just starting up. All we've done is prove the principles so far. There's a whole bunch of new stuff to do to feed in chemical and biochemical information of the body into the IT, into information systems, into digital health. And those companies, though, tend to be not the conventional healthcare companies. They tend to be the Googles, the IBM, the Microsoft, and so on, are beginning to think about this area. Sometimes I would complain naively, but nevertheless, they're charging in there, they're investing, they're putting people in there, and they will get there.
They believe that we can put some sensors and sense cancer at the end of the day.
Well, this is where sometimes I get a little worried as a technical person. I see a lot of promise and a lot of discussion about the potential for new products based on the need and the excitement there. But sometimes the technical understanding of the limitations is missing. So I like to, and sometimes I'm accused of pouring cold water on ideas because I say, but hold on, that's been tried and there are these problems. But you know, we can overcome those problems, but you have to realize the limitations of some approaches, and sampling is one of the biggest challenges, actually. When you want to make a wearable for detecting genomics, proteomics, metabolomics, detecting the chemistries of the bodies, sampling and getting the right sample that can give you the right information in a comfortable fashion is very, very tricky, and that's probably the biggest problem at the moment.
And you're holding now this fantastic thing, and you presented earlier that Sweden advanced a lot in the area of printed electronics.
Yes.
Do you believe we can take some leading position into this field?
Yes, I mean, this is one. Actually, I was attracted to Sweden. I've spent 35 years in the UK, and I tried to retire, but got sort of attracted back out of retirement by the rector of Linköping University. And one of the reasons I was so interested was we pioneered the idea of printing biological sensors, and that was one of the key elements of the success of the glucose sensor. But what they had in Linköping was printed electronics, and I could see the combination of printed sensors with printed electronics, and that's what we've realized in this device, where we've put together the sensing elements and the display, the battery, the electronics, and so everything is printed. Amazing. So this is a whole instrument, not just a sensor. And potentially you could print this like you print a newspaper, from reels running one to another, with literally, eventually, billions of devices being produced. So you could present instruments on packets, on pill boxes, on clothes, on elastoplasts, on whatever you wish. I haven't dreamt of all the possibilities yet. But the idea is very simple, very inexpensive devices that can be used in a wide range of applications.
And just to show to all our followers, this is basically the device, and it's slim as paper.
So you mentioned that it's very inexpensive as well. So why is it not very applied on a wide scale until now?
Well, first of all, it's brand new. I mean, we've only the first publication, academic publication on this, just came out 2 months ago, and we talked about it for the first time at the American Electrochemistry Society in Chicago, and that's come out in the Journal of Solid State Physics there. So first, it's new, but secondly, it takes a lot of money to develop these products, and you need to have a very clear path through to a product and a market. So it's finding the right application that this technology suits, because it's neat and it's cool and it's very clever. But for instance, if you have diabetes, type 1 diabetes, and you're measuring 6, 8, 10 times a day, you don't want to throw your instrument away every time. So that's not a good place for it. But if you have, for instance, you want to diagnose if you have kidney disease, and you want to go to the pharmacy and buy something, and you're going to just do it once, then that's a good market, because you don't want to buy a big clunky instrument and so on and so forth. You just get your card and throw it away. It's a convenience factor. You can have it in your pocket. You might want to use it to test allergens in your food. You might want to use it to test your drinking water in India. But we don't know which is the right place to start.
So the milestone for the Digital Health Days 2016 can be then you presenting the application and the adoption example for this kind of technology from stage, telling us that this is now being used. Yeah,
this would, yes, in the future, a future milestone.
Yes,
absolutely.
In the future.
We'd like to thank you for your very, very interesting insights on such an interesting perspective, and we hope to see you again next year with even more applications to this wonderful device.
Yes.
And thanks so much for joining us.
Yes, thank you.
Thank you.
Thank you.